Hi, I'm Rocco. I'm the projection designer and interactive technology expert for Pips Island. When I was brought onto the project, the Pips Island team was looking for a projection designer with experience integrating projections with the other design departments. When I'm not designing shows, I spend my spare time tinkering with technology and making stuff. Early on in the process, Rania asked me to see if I could come up with some ideas that used my hobby of playing with Arduinos, electrical engineering, and tinkering that could be put into the adventure of Pips Island. She asked me to pay special attention to the explorer's vests. I was inspired by Disney's Glow with the Show Mickey Mouse ears. This system used infrared receivers and emitters that allowed the Mickey Mouse ears to communicate with each other and create light shows during events. I thought, why can't we do something similar? My first idea was to install LEDs into the vest with a small microcontroller and an IR sensor. I could then trigger them with IR signals. We called the system the Spark Badge. During the adventure, the kids are presented with challenges and problems they have to overcome and solve. When they are successful, a spark is unlocked. When all the sparks are collected, only then can they defeat the dastardly Jules Voltaire and save the island. I went through a few prototypes and it worked okay. We had some issues with reliability. If the IR sensors couldn't see the signal, the lights wouldn't trigger, so I had to go back to the drawing board. I looked at different wireless solutions, but most were either too expensive for the number we needed or too complicated to scale up. That's when I discovered the ESP8266 Wi-Fi module. It's been around for quite some time, but I had never had need of Wi-Fi on any of my projects. It's a super cheap Wi-Fi chip with the ability to act as a microcontroller like an Arduino. I thought, this is perfect. Now I just need to marry the chip with some LEDs and I'll have what I need. While researching the ESP8266 and LED combos, I came across a design by a New Zealand-based maker, Bertus Kruger, aka Protoneer. It was exactly what I wanted. It was even using the same LEDs I was already using in my prototypes. The LEDs are called NeoPixels, and are from the amazing New York City-based Adafruit where I have ordered much of the supplies I use in making prototypes. Even better, Bertus sells ready-made modules from his eBay store. I contacted Bertus and ordered a few of the modules and got to work on how they would all communicate. We are in the middle of the Internet of Things boom, and I thought that an IoT system would work great. The Internet of Things is taking everyday devices such as your lights, thermostat, air conditioner, and various sensors such as temperature or humidity, and adding control of them over the internet. What I settled on is the Blink app. Blink is an app for your cell phone that lets you program Wi-Fi connected microcontrollers such as an Arduino or my Wi-Fi chips and control them directly from your phone. Here is a nightlight I made that I can turn on from my phone. It works by having your phone and the device both connected to an online server over the internet. Of course, I didn't want to control the sparks over a phone, and I didn't want to have to rely on an active internet connection for it all to work, so I made my own Blink server. This is how it works. The system is made up of a Wi-Fi router, Spark badges, a controller with some switches, and a Raspberry Pi running the Blink server. Everything is connected to the wireless router. The Spark badges constantly ask the Raspberry Pi what number the controller is sending. When no switch is triggered, that number is 0. When you flip a switch, the controller sends a new number to the server and the Spark badge gets to work. Every time a new switch is triggered, another number is sent and the badge does its thing. Another cool feature of the Raspberry Pi server is that I'm able to update the software for the badges wirelessly. Whenever I make changes to the code in the Arduino programming environment, I can upload the new software to the Raspberry Pi server, and when the sparks are powered on, it checks for an update, and if one is present, it downloads it and updates itself. This has been a big time saver since the other way to upload code was attaching this adapter directly to the modules and programming them one at a time. Let's see the Spark badge in action. Please join us at Pips Island, starting this November at the Skylight Modern on 27th Street between 10th and 11th Avenue, near the High Line. Learn more about Pips Island at pipsisland.com.